Alright guys, today we are looking at binomial distribution and how to construct it. So binomial distribution is one type of probability distribution that shows the probabilities of the outcomes of a binomial experiment. So a binomial experiment has some number of independent trials. Each trial has only two possible outcomes, success and failure. So maybe you're trying to measure the probability of getting heads when you flip a coin. So the probability of success would have to be the same for each trial. So in our case, if we were flipping a coin, the probability should be 50% or 0.5. Then the probability of failure is that 100% or 1 minus that probability of success. So your formula then that you use is the probability of k successes is using combinations, the number of trials that you do, that's your n, and then the number of successes that you get is your k. So n is number of trials, k is number of successes, p is probability of success. So then notice your probability of success is raised to the k power, the number of successes that you have. And then your 1 minus that probability is the number of trials you did minus the number of successes. So basically your probability of failure raised to the number of failures that you had. Okay, so at a college, 53% of students receive financial aid. So that's going to be our success, is 53 are receiving financial aid. In a random group of 9 students, what is the probability that exactly 5 of them receive financial aid? So for that, we're going to say we have a group of 9. We want to know how many are successful, how many times 5 are successful. So our probability of success is 0.53. We raise that up to the 5th power. And our probability of not success is 1 minus 0.53. Well, 1 minus 0.53 is 0.47. And that's raised up to the 9 minus 5 power. So 9 minus 5 is 4. So notice that those two numbers, the 5 and the 4, will add up to your total. So then if you put that in the calculator, we get 0.257 approximately. So a little over 25%. All right. Create a binomial distribution in a histogram for the class of students. Well, binomial distribution is where we are finding all of those probabilities. So I want to know when k equals 0, k equals 1, k equals 2, all the way up to k equals 9. So you're going to put in 9, 0 successes, 0.53 to the 0, and then 0.47 to the 9th, and see what we get. And we should get 0.001. You already have k equals 5. So that was 0.257. Alright, I'm going to fill the rest of these in. You go ahead and try them on your own. If you need to pause the video to do that, that's fine. slide this so you can see all of those. So there's k equals 0 to k equals 9. So our listing of all of those values are binomial distribution. And then a histogram looks like a bar graph where they all are touching. You'll notice we need to go from 0.001 all the way up to 0.257. So I'm going to go by 0.05. And this is 0. So then 1, 2, 3, 4, 5, 6, 7, 8, 9. I didn't quite give myself enough space there. Okay, so if I fill these in, 0.001 is barely coming off of here. 0.011 is still barely off of there. Then 0.051 is at 2. Then 0.135. 0.228. And 0.257, just above that 0.25 mark. Then 0.193 is right below that 0.20. 0.093 is below that 0.10. 0.026 is about halfway to 0.05, and 0.003 is back down here. So there's our histogram of our binomial distribution. One thing, if you would like to try to type this in your calculator, you can go into Y1, and this will give you all of these values as well very quickly. We know that we have 9 trials, and we want to figure out our X values from 0 to 9. So we have 0.53 to the X. And then we have 0.47 to 9 minus x. So if you plug that into Y1, you can go into your table, you can find all those values. You can even then see that graph on your graphing calculator, and that's something that if you would like to see in class, let me know, and we can go over that. So then, this is still part of the same question. It says, what is the most likely outcome of the survey? Well, if you look at your histogram, it's easy to see our highest bar is at 5, and that's our biggest number there. So the most likely outcome would be 5 students receiving financial aid. All right, what is the probability that fewer than 3 students in the class receive financial aid? So we want to know that the probability K is less than 3. So that would be the probability that K equals none, and, well, or the probability that K equals 1, or the probability that K equals 2. And so since it's or, it can be any of those things. We're adding in between. So if you go back, K equals 0 was 0.001. K equals 1 was 0.011. And K equals 2 is 0.051. So if we add those together, we get 0.063. All right, types of distributions. So we could have a symmetric distribution where it can be divided into two parts that are mirror images, or we can have a skewed distribution. That's a distribution that is not symmetric. So, describe the shape of the binomial distribution that shows the probability of exactly k successes in 8 trials if the probability is 0.5% and if the probability is 0.9%. Well, the answers are right here. So this is what I want you to see. Is with with 0.5, that's 50%. And so you have just as equal chance of a success as a failure. And so you can see how your highest number of successes really is centered there at 4 of 8 trials. Very few times would you have no successes or would you have all successes with a 50% probability. Whereas if you look at the part B, that if it's a 90% success rate, there's a much higher chance that you're getting 7 out of 8 successes or 8 out of 8 successes. You can't even see the 0, 1, 2, and 3 on that number of successes. So this would be a symmetric versus this one would be skewed. Alright guys, that's all I have for you today. So if you have questions, feel free to come in and see me. Otherwise, I'll see you in class.